So the hardest problem in this section of multiplying and dividing rationals is when you are looking at something with three expressions all multiplied and divided together, and you just have to sort out what's going on. And sometimes you even have non-monic polynomials to factor. That's a polynomial when the number in front of the phi squared or the x squared is an obnoxious number that's not just one, so it makes the factoring a little harder. So this is definitely a challenge problem. And the way you go through it is, well, number one, don't panic. It's just more of what you know. You should know everything in here by now. But I want to point out something at the very beginning of this thing. See that division sign right there? You guys know how to handle a division of a fraction, right? You flip over the thing that's being divided by. I just want to caution you and make sure you don't flip over everything that comes after the division sign. That would be wrong. Now, if it had parentheses in it the way I've drawn these parentheses, then yes, you would go ahead and flip everything. But it doesn't have parentheses. That means the only thing that's getting flipped is the term that's being divided. Okay, so now with that out of the way, let's get forward. Let's get some of the factoring done here. I'm going to start with this guy. Okay, 5x squared minus 29x plus 20. Let's do a big X for this guy. 20 times 5 is 100. Negative 29 comes down, so I need two things that add to negative 29 but multiply to 100. And think. 4 and 25. Okay, so minus 4 and minus 25. So now we write that as, not x. We're going to write this as 5 minus 4 over the first term of 5 and 5 minus 29 of the first term. I'm sorry, not 29, it's 25. 25 over 5. And if you're not seeing where these numbers are coming from, I'll just do a little quick reminder. And by the way, if you're comfortable with your factoring, then you can probably skip all of this. I'm just going over these in case you are not comfortable with your factoring. Okay, so the 4 goes over here, the 25 goes over here, and now we need to simplify these fractions, in the case of the one on the right, that's just 5 minus 5, or rearrange them so there's no denominator by bringing the denominator over here. Remember, this is the factoring trick we learned back in polynomials. So this is the factored form of that top left. And the only other thing in here I don't think I can do in my head is, let's see, right here, this one. Okay, so that is another difficult to factor one. We're going to make another big X for that. And 5 times 4 is 20. The middle term is negative 9. I'm going to find some things that add to negative 9 but multiply to negative 20. It's negative 4 and 5. So this is going to turn into what? We've got phi minus something, and the somethings are those side terms. So it's 4 over 5 and 5 over 5. And rewriting that the same way we did in the first one, this becomes 5 phi minus 4 and phi minus 1. And I think you'll find that if you multiply these together, right here and right here, you will find the original polynomials from the top of those fractions. Okay, so let's take those and start rewriting everything back again in factored form, because we need factored form before we can proceed with this. Let's write it all out. This top left is going to be 5 phi minus 4, and then phi minus 5 comes after that. The bottom of it is easy with the GCF. You just pull 6 out and you get 5 plus 2. And instead of writing divided by, I'm just going to write times, and I'll do that flipperoo thing. Okay, instead of going on the top right here, that's going to come down to the bottom. So that's what we found as 5 phi minus 4, phi minus 1, and the bottom of this thing goes to the top. So I see that is a greatest common factor of 3, and probably phi minus 5 and phi plus 2. Okay, and next we have one more multiplier over here, but this is easy. It's just a factor of 10 phi as my GCF, and what's left inside is phi minus 1. there. And on the bottom, we're almost there, folks. Phi minus 5 and phi minus 2. This is honestly more than half the work, because now we just come through here and start whapping things. Whap, whap. We're looking for common multiples or common factors, and I'll just keep using the same color every time I cross something out so you can see where all these pairs come from. There's one, x plus 2, and what else do I have? This is an interesting one. See that number 6 lower left over here? 6 cancels out with 3 to leave a 2 behind, and then the number 2 cancels out with 10 to leave a 5 behind. Okay, so now what's the, oh, you know what, there's still one more thing. Am I running out of colors here? Let's use this one. Phi minus 1. There's a factor. So, gosh, almost everything's crossed out. What's left here? Let's write the total. We've got phi minus 5 from the middle expression, and a factor of phi from the right expression, and it's all over phi minus 2. Okay?